spherical mirrors. So in the syllabus, the next reflection is on the spherical mirrors. Spherical mirrors. Spherical mirrors. Suppose if this is a sphere, this sphere is having two surfaces. Two surfaces. What are the two surfaces? This surface is called convex or concave? This outer surface. How do you decide? This is cave, this is cave, this is vex. So this is called concave surface. This is called convex surface. If the reflection occur from the concave side, because in the mirror one side is polished, one side is reflecting side. So if the reflection occur from the concave side, then this mirror is called concave mirror. So if I say what is this mirror? This mirror is called concave mirror, because if the reflection will take place, it will take place to which side? To the concave side. Alright, that's why its name is concave mirror. Similarly, if this side is polished, then this is called convex mirror. Why? Because in this case, clearly the reflection will take place from the convex side. So this is how you give the name. This is how you give the name to the mirror. The spherical mirror is the part of the sphere, some part of the sphere, and if the convex side is polished and concave side is reflecting, it is a concave mirror. If concave side is polished and convex side is reflecting, then it is convex mirror. So in general, you show the concave mirror like this and convex mirror like this. Otherwise, you can show like this also, but only the difference in the polishing side. Alright? Alright. So this is concave, this is convex. And now comes the other terms. What are the other terms which is related to it? So first of all, it is the piece of the sphere. It is the piece of the sphere, and then it is having some specific term. For example, if I have a concave mirror, let us say, then the center of this piece is called, what do you call this as? Point, the center point. Pole. Okay, this is called pole. Since it is the part of the sphere, so this part of the sphere is also having somewhere its center. This is here if you see, then this will be the center of this sphere. So if you join the center and the pole, what is this called? Principal axis. So if I join the center to the pole, what it is called? It is called the principal axis. Alright? The center joining the pole is called principal axis. So pole you have, principal axis. This is also called center of curvature. And what else? Focus. Where is focus? What is focus? In between is not necessarily. By the calculation it will come that it is in between, but focus is not the point which is in between. Focus is the point from where the paraxial rays will pass after reflection. The paraxial rays will pass after reflection. What is paraxial ray? What is paraxial ray? So now one more term is coming. Who will tell what is paraxial ray? Parallel to principal axis. Is it? Absolutely correct. Paraxial ray, generally students are having wrong impression about it. It is not only parallel to the principal. Every parallel ray which is parallel to the principal axis is not paraxial. The ray is parallel to axis and close to it. Only those rays are considered to be paraxial. Only those rays are considered to be paraxial. Alright? So you got to know about pole, focus, center of curvature, paraxial rays and principal axis. Right? The effective distance of the mirror. The effective distance of the mirror is called aperture. Okay, so more surface is there, larger is the aperture, which is basically depending. More is the aperture, more rays will be reflecting, so they will decide the intensity of the image. Because more reflections will be there, definitely the image will be formed more bright. So more bright means more intensity of the image. So this area is called aperture, or this distance is called aperture. How large the mirror is. Aperture. Then comes the distance PF. So from the pole to the focus, this distance is called focal length. This distance is called focal length, which we denoted by F. This PC, this is called radius of curvature. Radius of curvature, which is denoted by R. Alright, which is denoted by R. Now, if I do the calculation, this F is equals to R by 2. This is F is equals to R by 2 only for paraxial rays, not for all the rays, but only for paraxial rays.